Hey everyone, welcome to our webinar on how to prevent the dreaded DBA burnout. We're glad to have you. While we wait, today we are talking about something that almost every database admin and IT ops person in this meeting already feels in their body, the gap between the week you planned and the week you actually had. So we are calling it the 24 plus hours of firefighting versus 2 hours of strategy. And by the end of next hour, my goal is that you walk away with an actual framework, not just sympathy for closing that gap. Here's the map. So here's the agenda, what we'll cover in the next 60 minutes. So firstly, we'll start out with the burnout reality itself. What's actually eating the work week, backed by real numbers, not just vibes. Then we'll get into why traditional monitorings can't fix this before walking through an observability framework that can. From there, we go hands on, like we are turning insights into action. And this is a new territory for a lot of DBA focused audiences, where we'll also have a bonus section on where cost and performance actually intersect. Then there's the fun part where we'll be talking about how Manage Engine helps with all of this, and followed by a live demo. So let's jump in. So the section 1 here is about the DBA burnout reality. So let's talk about why so much of the week just disappears. I want to preface this by saying that I'm not a professional dealing with psychological aspects of a burnout. I'm a technical expert here to dissect the technical aspects of burnout, from hours spent on troubleshooting database issues and how to overcome with simple strategies and habits. Here's a number that I want to sit with for a second, 55%. So that's the average percentage of hours you'll sit fixing database issues in a week. That's a whopping minimum of 24 hours a week. No wonder admins are getting burnt out. So if you compound that over a year, that's more than 54 days a year, which amounts to 1/5 of the year just on database issues. Let that marinate. So let's move on to more statistics that support this claim. 20%. That's the median share of work week that reliability teams spend on toil. Toil is nothing but manual, repetitive, non-value add work, not on their actual job, just troubleshooting. So here's what makes this number worse than it actually looks. So if you look at the trend behind it, this is a Catchpoint's SRE report tracked over 5 years. So the toil was at 40% in 2020, and it was going down to 14% in 2024. But then in 2025, it was the first time that it reversed. It ticked back to 20%. And it's not isolated to that one metric. The same report found that the time spent on operations climbed too, from a median of 25% to 30% of the way. This is happening despite everybody adopting more AI tooling and more automation. So whatever we've been doing to fix this problem structurally, it's not working on its own. So when toy eats this much of the week, the strategic stuff like the capacity planning, performance tuning, actually architecting where you're headed, it just doesn't happen. So there's no time left for it. So what does that toil actually look like day to day? It's not one dramatic thing, it's like 5 categories of small fires. So we have alert response and triage, we have incident troubleshooting and emergency fixes, performance complaints and escalations from frustrated users, cross-team coordination and recurring issues, and manual backup, patching, and maintenance. So when you take that in the form of a graph, say this is your entire, the 100% represents your entire week, 35% alone is spent on alert triage and response, and 22% is spent on incident firefighting, 18% is spent on manual checks and maintenance, 12% with cross-team fire drills, and only 13% of the actual work week is spent on strategy and improvement. So that's almost 87% of your time spent on something else other than strategy and improvement. So the cost just isn't hours on a timesheet. It's compounding. 44% of organizations had an outage in the past year that traced directly back to a suppressed or a ignored alert. So that's not a missed alert, it's the one that fired and got buried in noise. And 70% of SREs say on call stress has contributed to burnout and attrition on their team. This is not a productivity stat, it's a retention stat basically. And 57% of on call teams say fewer than 30% of the alerts they receive are actually uh, actionable. So, more than two-thirds of what's pinging people on average is noise. So here is the part that explains why this problem persists even in organizations that care about it. So there's a real perception gap between the people doing the work and the people funding the fix. So 74% of executives believe that the organization is already using AI to actively address this alerting and reliability problems. But only 39% of the engineers agree. So that's a 35-point gap. And that gap is not really about AI. It's a gap about whether the leadership has an accurate picture of what's actually happening on the ground. That gap is why budget requests get denied, why the headcount doesn't get approved, why we need better tooling doesn't land, because the person hearing it genuinely believes that the problem is already solved. If you felt that disconnect with your leadership, this is why it's not just you. So if the problem here is real and measurable, why haven't traditional monitoring tools solved it? Now, this is section 2. So the part of the answer is just complexity. Most environments today aren't running on one database engine, they're running on a mix. So we have on-premise system, which has legacy infrastructure. We have private and the public cloud. We have relational databases. We have document stores, and we have cloud native managed services along with the multi-cloud sprawl if you're using different cloud services. So this isn't just some organization's problem. It's basically the default now. A Flexera State of the Cloud report says that 73% of the organizations now run a hybrid cloud model, which is up by 3 points year over year. So every one of these environments still needs a database strategy that spans both sides on top of the engine sprawl above. So what do most teams do in response to that complexity? They add a tool for each piece. An Oracle console here, a cloud metrics dashboard there, a APM tool, a log viewer, a ticketing system. It's just like compounds over and over. So here we have another stat which says that 29% of enterprises run on 5 and more database platforms simultaneously. What this means is that they will have disconnected dashboards. So every single console for every single engine. So what this means is there's no single source of truth for that performance. Alerts fire in isolation, and correlation becomes a fully manual job. And that manual correlation is eating the exact hours that should be going into the root cause work instead. So here's the thing about tool sprawl. It just doesn't create inconvenience. It also creates blind spots. Real problems hide until they're user facing. So these are the common database issues hidden in the dark. You'll be dealing with deadlocks and locking conflicts. You'll have resource exhaustion, such as CPU, memory, and storage pressure. You'll have unoptimized queries, and you have the schema drift between environments that only shows up after a deployment when it's already too late to catch in review. That's the problem. Now let's talk about the actual shift in thinking that it fixes it. So we have the issues that goes undetected. So in traditional monitoring, you're predominantly working with thresholds. So what the thresholds catch are hard failures and outright crashes, obvious response spikes, and alerts on metrics someone remembered to configure. But what actually slips through is the gradual query plan and index drift, log contention building that's building over hours, like not seconds, building over hours, days, etc. Schema changes with no immediate symptom, and edge cases nobody set a threshold for. So these are the things that go undetected, that slips through. But these are not caught by traditional monitoring tools. What do we do here now? That's what we're going to discuss today. And this is where we talk about the database observability framework, where monitoring tells you something is wrong, but observability tells you why. So this is the single most important distinction in the whole talk. So let's be really precise. Look, monitoring versus observability. Monitoring tracks down the metrics against fixed thresholds. It answers one question, whether it's up or down. It's reactive, and the alerts are after the impact. And it just basically adds one more alert to triage, and it is siloed per tool or a database engine. But observability is different. It connects metrics, logs, queries, traces together. It answers much more useful question like why is it slow and what's likely to break next. And it's proactive. It surfaces the drift before the impact and not after. So, and it's critically unified across your entire database fleet, and it's not fragmented to a particular tool. So if you remember one slide from this entire section, I want it to be this one. Monitoring tells you what, observability tells you why. So what does that actually look like architecturally? You take everything, on-prem databases, cloud-native databases, cloud infrastructure, containers, legacy systems, applications, etc. And then you, instead of routing each of those into those own separate tool, you funnel them into one unified observability layer. And the of that layer isn't just a dashboard for the DBAs. It's one dashboard shared by the DBAs, IT ops, SREs, and leadership together. Remember that 35-point perception gap that I mentioned in section 1? So this is the structural fix for that. When everyone's looking at the same data, that gap has nowhere to hide. So here's the operating model that ties everything together, and it's very simple, 3 steps. So in step 1, we have find, where we need to detect the anomalies and the drift the moment they appear. By drift, I mean the deviation from the ideal performance. So when you scan your whole database, it's not just one system that needs to be instrumented. So here in step 2, you analyze, you correlate the metrics, the queries, and alerts to pinpoint the root cause, not just the system. And 3, you need to fix it. You need to resolve it with confidence and actually verify the performance is restored before your users noticed anything has happened. Hold on to this framework because we are going to use it again in a few minutes, and we're going to come back and extend it in the next section as well. Observability helps us detect and resolve issues before they impact users. So here are 3 common categories of drift before users will ever feel them. So we have split them into 2, without observability and with observability. Firstly, we have the query plan drift. Without observability, query performance gradually declines until it causes an outage. But with observability, the anomalies are detected early, allowing you to fix the issue before the users notice any impact. Second, log contention buildup. Without visibility, block transactions accumulate and eventually exhaust database connections. Sorry about that technical glitch. So like I was saying, the second one is log contention buildup. Without visibility, block transactions accumulate and eventually exhaust the database connections. So with observability, abnormal wait times are identified early, which prevents a major incident. Thirdly, we have pass storms. A new deployment can introduce an inefficient SQL statement that drives CPU usage higher. Observability detects the unusual hard pass activity within minutes of deployment, which enables rapid correction before the performance suffers. The key message here is simple. Observability shifts teams from reactive troubleshooting to proactive prevention. which helps resolve issues before alerts fire and before users are affected. All right, this is the meatiest section of the day. So let's take our time here. This is where our framework gets practical, turning insights into action. Let's start with the before and after. So before you, the root cause investigation means manual log digging across disconnected tools. Root cause relies on whoever's tribal knowledge happens to be on shift, and it takes hours, sometimes days, just to confirm what actually broke. But after this, automated anomaly detection along across your entire fleet with a guided drill down query by query and resource, and the root cause is confirmed in minutes instead of days. That's not a marginal improvement. That's a fundamentally a different experience of an incident. So this is what we want to achieve by the end of this session. So this slide here shows how AI-powered observability actually helps teams detect and resolve issues much faster. So we expect a 50% faster issue diagnosis reported by teams using automated versus manual approaches. So here the reason is simple. AI-driven anomaly detection continuously learns what normal behavior looks like for your environment and automatically flags meaningful deviations, which reduces the noise and alert fatigue. More importantly, it doesn't just tell you that something is wrong, it helps identify the root cause, whether it's a slow query, log contention, resource bottleneck, or configuration issue. The result is faster detection, faster troubleshooting, and quicker resolution before minor issues become major incidents. Now let's go back to the three-step framework from that section 3, because it actually needs a fourth step. Find, analyze, fix, and then prevent. Here's the logic. Every incident that gets fixed but never gets converted into a rule or a baseline or an automated check is an incident you are going to have again. Fixing it once is necessary. Turning it into a permanent safeguard is what actually moves you toward that 2 hour of strategy number in our title, instead of staying stuck at more than 24 hours of firefighting forever. So the next 2 slides are the signals to catch to make the prevent a reality instead of just a good intention. Let's look at this scenario that we can all relate to. I'm sure you're all aware that the FIFA World Cup is going on. So imagine that you are broadcasting the FIFA World Cup final to millions of fans. The game is tied into the final minutes. The stakes are massive. Here's what our database bottlenecks actually feel like in the stadium. First one is re-encoding nightmare, which is akin to workload fingerprint passed on. We'll get to that workload fingerprint passed on in the next slide, but before that, I want to explain this scenario. So the millions of fans log on to watch, right? But instead of just streaming the match, your broadcast equipment decides it needs to completely rebuild and re-encode the video feed from scratch for every single person who clicks play. The servers will instantly melt. In the DBA world, that's an unparameterized query flooding the cache. And secondly, we have the delivery bottleneck. This is when your broadcast trucks are pushing out a perfect feed, but the local internet is frozen. The data is backed up at your door. Third one, we have the confused director. Picture the striker driving down the field, about to shoot, and suddenly the live camera cuts away from the ball and zooms in on a guy eating nachos in row 24. Why? Because the camera director was working off an outdated stadium map. And finally, the jam turnstile. So think of the main entrance turnstiles at the stadium, right? You will have to wait until your QR is scanned. So one fan gets stuck because their ticket won't scan. They won't move and they won't let anyone else pass. Within minutes, the angry crowd of thousands of people behind them are completely blocked. This is a lock wait. Now I want to get genuinely tactical for a minute here, because I think this is worth screenshotting, even if you forget everything else today. These are 4 signal patterns. So 2 signals are listed here. 2 signals will be listed in the next slide. Here we'll have what to watch out for, what it actually means, and what to do about it. Think of it as a triage cheat sheet that works no matter what tool you're using. So the workload fingerprint here means that your application, whatever uh, application you have, if it has a negative effect on your database, this is what we mean by workload fingerprint, rather than what's broken inside the engine itself. So the first pattern here is the throughput pattern. Here, there will be a spike in parsing overhead, that is hard passes, alongside a flat throughput. Now, think about that analogy with re-encoding nightmare. This is exactly like that scenario where a recent deployment that introduced unparameterized floods the query cache and burns the CPU on compute instead of actual work. This means is that you will get a lot of requests, but the requests are not being processed. So here the immediate fix is to have a conversation with your dev team and rewrite the entire dynamic SQL to bind the variables or enforce parameterization at the engine level as a stopgap. So next workload fingerprint we have is related to concurrency. So if there's a surge in active sessions combined with the spike in network IO weight, it means that the database is doing its job fine. It's the application that can't consume the results fast enough, so it buffers backup. So remember when we talked about the delivery bottleneck? This is exactly like that scenario. So the immediate fix is to check for n+1 query loops or giant paginated payloads. Here you need to scale the connection pool or cap the maximum concurrent DB connections temporarily so that this doesn't cause an issue in your application. So, and here we talked about the workload signals, right? So we'll talk about the engine signals here in this slide. These are also very important to take note of. So these are engine signals, meaning that these are from the databases themselves. So the third pattern here is from active session history, that is high disk IO weight plus sudden planned regression. What this means is that a query has broken. Now, with regards to the scenario, this would be the case of the confused director. It happens when the database statistics go stale. The optimizer gets confused and takes a slow, massive table scan instead of doing index scans. So the immediate fix is to manually update the statistics or to run or analyze reindex on the affected table, may enforce a query plan to hint restore the good known path without a full restart. And finally, number 4, from wait states. So this here, the critical signal that you need to watch out for is high lock or latch wait plus low CPU. Think about the angry crowd because of one improper scan at the waiting gates. One stuck transaction or process at the application layer holds on to a row, blocking dozens of other sessions until the whole system grinds to a halt. This combination means that you're bottlenecked on concurrency, where threads are sitting idle, waiting on a resource, usually because of an uncommitted transaction somewhere. So here the fix is to isolate the blocking session via system views and safely terminate that specific PID and tighten your connection timeout so that this doesn't recur. So here are the 4 telemetry pillars that I talked about. I want to reiterate that. So we have the workload fingerprints. One is throughput and concurrency. And then we have the engine signals, which is active session history and wait states. Here, the critical signal that you need to watch out for is a pass spike for hard pass. And we also have a flat throughput, meaning that the throughput graph is not going up or down. Then for concurrency, you need to watch out for active session surges and network IO waits. And engine signals, you need to watch out for high disk IO weight and sudden plant regression. So if that happens, then there is a query that's broken. And then you need to watch out for this particular combination of high lock latch weight plus low CPU. This means that a query is blocking other queries from acting out, and get resolved. So catching it before it becomes an incident. Here's the thing about those four signals. So the telemetry in the last two slides isn't for triage after something breaks. If the same signals watched continuously will let you fix the problem while it's still invisible to the users. Here are three quick examples. Number one is index bloat caught at 60% density. So a scheduled check would flag a leaf page density drifting below that roughly 70% baseline on a high right table. It gets rebuilt in the maintenance window before the query times will actually degrade. So if you have a scheduled page check, it will tell you that there is something wrong with index fragmentation. So if you get that before it goes below the 70% baseline, you will be able to automate the defragmentation within the maintenance window before the end users or before it goes beyond the 70% baseline. Then the second one is the connection creep, which is caught before the ceiling. So if you alert at 70% of max connection instead of 95%, which would be a critical time, it will buy you time to install a traffic management tool, which is a pool, right before the server runs out of room and crashes the entire website. And number three, we have the stale statistics, which should be refreshed automatically. You have a scheduled analyze after every bulk load. It keeps the planner working from current row counts so that the plan regression from pattern one, where a minute ago, it never gets the chance to happen again. So which of these three already exist in your environment today? Curious, you can jot it down in the chat box also. So here is the metrics that matter, how to watch it, and what kind of threshold baselines you need to set up. So we have the query latency. So we have 8 signals here. So the query latency, if you look at it, your query execution times, if they spike to more than 2 times your normal baseline, it is an immediate red flag. This usually means that you're dealing with an execution plan regression or resource starvation, or queries getting stuck waiting on a lock. Then we have the lock wait time. If it is more than 500 microseconds, anything higher than that, it means that an uncommitted transaction or a serialization bottleneck is forcing the other queries to sit in line, making everything slow down. And the next is active session. If it hits over 80% of your pool capacity, you are dangerously close to connection pool exhaustion. This is often caused by sudden surge in traffic or a runaway query loop eating up all of your available slots. Then finally, you have the buffer cache hit ratio from the first row. Coming out the top row is the buffer cache ratio, like I said, which you always want about 95%. If it drops below that, it means that the memory pressure is forcing the database to skip the fast cache and pull data via expensive low disk reads. Then we move on to the replication lag. If your replica falls more than 30 seconds behind, the primary database or your read workloads are going to start seeing stale data, which will break the entire user experience. Then we have metrics that are related to throughput. If it is flat and has a high CPU, meaning it's using a lot of CPU, this points directly to past storms or a query plan bloat, where the system is burning major CPU cycles without actually processing transaction. So you need to watch out for that. We watch those past storms by watching the hard pass ratio. If it exceeds 10% of your total number of passes, it means that an unparameterized SQL query is flooding the query cache. And finally, we look at the I/O wait percentage. If the database spends more than 20% of its total time just waiting on storage, you've hit a massive hard disk I/O bottleneck. This is your cue to either have missing index or broken execution plans, which will force tables to scan sequentially. So here's habit number one, and it's really a philosophy shift more than a tooling change. Instead of static thresholds, we use context-based threshold against a baseline. So, for example, if you have a static threshold for CPU exceeding 80%, or a cache hit dropping, or a connection count that is spiking, or a replication lag that's detected, use a context against a baseline instead. Like, for example, you can use a query latency crossing its own historical baseline. This historical baseline would only be possible with the help of a observability tool, because there you will have machine learning based anomaly profiles or threshold profiles, which basically gathers the historical data and finds a new baseline for the same. So the cache hit ratio, when it's compared to the normal workload for that specific time period, not a universally flat number. Then connection counts, which is compared to the baseline for that time of the day. So it basically what it means that there could be different number of connections during different times of the day. For example, if you take it during lunch hours, it might be lesser compared to when it's peak hours, say 5 o'clock or something. So it really needs to be compared against a baseline for each time of the day. And finally, the replication lag, which should be flagged only when it's outside a scheduled batch window. Here's the line I want you to walk away with. A metric without a baseline is just a number. So CPU at 80% can be healthy under a batch job, or it can be a 5 alarm fire at 3 a.m. on a quiet Sunday. The raw number cannot tell you which is which. It only a baseline with context can. So let's go to habits that make prevention stick. So you need to have a quarterly health review and a postmortem every time. We'll go through what you do in a quarterly health review now. So 30 minutes once a quarter, you need to have this review. Review your incidents for recurring patterns. You need to check the table growth rates against your index capacity. Review your slow query trends for anything new that's climbing on the list. So check your peak connection counts against your ceiling. Add a test backup restore if you haven't in the last 90 days, because a corruption found in testing is a minor annoyance, but the same corruption, if it is found during a failover, is a major outage. So you need to do this for 30 minutes once a quarter, which is, if you take that in context and take that in this scenario, it's nothing basically when you're spending 24 plus hours each week. And the second one is a postmortem every time there's an incident, which should be completed within 48 hours, by the way. So it's not just for big incidents, every single incident. For here, you need to have 4 parts. One is, it starts with the incident summary, with the severity of it, the duration of it, the number of users that have been affected. Then you need to have a timeline listed, like the first alert through the service restored, from the first alert through the service when it is restored. You need to have 5 whys. So working backward until when you hit the systemic cause, not just the surface symptom. And then finally, you need to have the action items, each with the named owner and the actual due date, not just a note that trails off to nothing. You need to have an action item with the DRA, with the due date, and how it affected the entire incident. So both of these habits are free and they work no matter what monitoring tool. So that's the point. Prevention is a process discipline first, and then a product feature. We'll come back to how the right tooling makes both of these habits dramatically easier to sustain later in the session. But this is basically the habits that you need to perform so that your strategy is in place, while it makes your hours working on the incidents or troubleshooting the database issues go low. So that is about this. And we have a bonus section here, the FinOps cost plus performance bonus. This section goes a little beyond the core burnout topic into a territory of DBA focused webinar, into a topic that DBA focused webinars don't touch at all. It's about the cost. So here's the setup. Performance to dashboards and cloud cost reports usually they live in different tools, right? Owned by completely different teams. And that split is exactly why over provisioned infrastructure can survive for months without anybody question it. Nobody is looking at both pictures at once. So, two things to close that gap. First one is having a query level cost attribution. So, instead of having why is your cloud bill up, which is a question nobody can act on, you get to get down to exactly which queries, which tables, which tenants are actually driving the compute and IO spend. That's an unanswerable question to a specific fixable one. Secondly, we have the idle resource detection, where you can surface the over provision instances uh, from a traffic spike or detect a dormant replica where no query is reaching, identify index bloats, and right size it immediately. So, this can be done with the cloud cost tool, and this you can use your own capacity planning tool to identify both of these. When you work with this, you will be able to bring down your costs so much that your leadership would thank you. Now, moving on to section 5. So, this table is actually the direct answer to our title. So 24 hours, more than 24 hours spent on troubleshooting versus 2 hours of strategy. So how Manage Engine as a company, how we help with this is what we're going to do in this section. So first of all, we provide database observability for real database admin workflows. So we have unified observability where you get multi-engine visibility into relational, NoSQL, and cloud-native databases, both on-prem and on multi-cloud, in a single pane of glass. So then we have the root cause pinpointing, where we drill into the exact issues. So where we have more confident root cause analysis, and then we have the automated remediation based on the root causes, where you can trigger automated responses to certain incidents so that the next time it happens, it'll get automatically remediated instead of alerting you. Then we have the AI driven anomaly detection, which alerts you based on dynamic baselines, where it'll compare your baseline with that of historical baseline or the performance and alert you basically. And then we have a app to database correlation, where we basically have code level analysis and down to the database transaction and traces. So if it will end the developer versus DBA finger pointing, where the developer says it's because of the database and the database admin says it, no, it's because of the application that the latency is happening. And also we have the multi-channel alerting, where you can get actionable alerts through Slack, SMS, or email the instant a real issue emerges. And so, like I said, we have a unified visibility across the entire database fleet. So inside a Manage Engine, we support the monitoring for these databases. So it basically support both on-prem databases, legacy systems, cloud databases, etc. Like I said, we have the Oracle RAC and multi-tenant SQL servers, MongoDB, SAP HANA, Cassandra and Couchbase, IBM Redis, data Sybase, AWS RDS and Aurora, Azure SQL, and Google Cloud SQL. So now that I've given you a brief introduction about our tools, you will get a poll on your screen asking you whether you want a demo of this product. So please click yes if you want a free demo of this product. And with that, I move on to the next one. So here we remember the first remember in the first section, I showed you a slide where we compared the before without observability, where we say these are the 5 things you are focusing on instead of strategizing. Yes. So this is the exact same slide. where we compare it with metrics after people using Manage Engine. So here, before people were spending like 35% on alert, triage, and response, versus when they started using observability tools, it became just like 5% of automated detection and response. And 22% of incident firefighting turns into 8% of targeted root cause, which is guided by AI. And the manual checks and maintenance accounted for 18%, but that is decreased to 15% of scheduled maintenance without any manual labor. Now, the cross-team collaboration remains the same, 12%, but here it's the fire drills, but with Manage Engine or with an observability tool, it turns into collaboration or reporting. And this is the part that's very important. So there, people only spent about 13% on actual strategy and improvement. But after Manage Engine, you get to spend 60% of your time on strategy, art, and optimization. So that is a 47% increase in the time spent on strategy and optimization. So you get the same 40 hours every week, but it's completely redistributed. So when you get to the psychological aspect of this, when you're spending more time on strategy and doing things that you actually love when it comes to databases, it reduces the chance of having a burnout, right? So that's what this entire webinar is about. So we're actually built for teams who'd rather strategize than firefight. Let's face it, nobody wants to spend their entire workday firefighting sudden server crashes or slowdowns. So we built our solutions for teams who rather focus on long-term strategy rather than crisis management. But there are people who would rather firefight than strategize. So if you are someone who would rather firefight or don't have burnouts from resolving incidents, then this tool is for people who would rather strategize, right? So that's why over 50,000 businesses worldwide rely on Manage Engine for application and database performance monitoring. When you look at what's included, you get like deep database, cloud, and ERP coverage in one license. It's completely collaboration ready, meaning that alerts route directly into the communication tools your team is already using every day. Plus, you get a total deployment flexibility to fit your exact infrastructure. So, with Manage Engine, you have three versions to choose from. So, to match your specific stack, based on your stack, basically, we have one is Op Manager Nexus, which is on-premises deployment. It's a bundled option where you can monitor your application servers, your network monitors, everything in one single console. We have the same thing on the cloud as well as a SaaS option. And finally, we have Applications Manager for dedicated on-premises application and database observability. So when do you need to choose cloud or on-premise? The answer basically lies in where you want your data to be. If you are okay with having your data in a data center, it will reduce your costs, obviously, because you don't have to have a data center. In which case, you can go for the cloud option, where you can go for the Op Manager Nexus cloud version. But if you are quite strict with your data about where they are handled, and if you value privacy and security of your data, and you have your own data center, then on-premises would be the right option for you. And under the on-premises, if you only want to monitor infrastructure, servers, databases, applications, then Applications Manager is the choice for you. But if you also want to monitor networks or virtualization, then Op Manager Nexus would be the right choice for you. So let's choose the right fit to move your team from reactive firefighting to proactive strategy, okay? And lastly, we have the live demo. Before that, I would also want to remind you that you will have another poll asking you which product you're interested in right now based on the information that I offered, whether you're interested in Op Manager Nexus on-premise version or cloud, or whether you're interested in the standalone product that is Applications Manager. Please click on the poll. It will help us in the long run. And finally, we are at the live demo section. This is the part of the webinar where we stop talking about the framework and I actually show it to you. So let's go. So in today's scenario, so you will have imagine a production database starts slowing down a checkout queries during a traffic spike. So this kind of incident normally kicks off a firefight, right? With an observability solution like that of Manage Engine, you would have the slow query that it would be automatically detected and flagged. No manual dashboard watching is required. And the root cause is isolated, like the exact query session or the resource behind the slowdown is pinpointed here. And the remedy is automated. Once you come across such a case, then you can actually remediate it with automated actions or workflows, so that the next time it occurs, you don't have to manually go and trigger a action based on it. So here is our setup. Let me show you our setup. This is our setup basically. Here, as you can see, these are the variety of infrastructure elements that we support. You have the application server, services, database server. So if you're in infrastructure, I'm sure you would have all these elements as well. But today we are talking about database servers, right? So let me show you how many database servers we support. We support more than 25 database servers. These are the list of databases we support. Here, let me show you the most popular database, that is MS SQL. So in order to find out the underlying metrics, we go to the MS SQL cluster. Here you get the performance details. So like I said, if it's caused by a query, imagine it's caused by a query. So here, if you go to the performance tab, you will be able to filter it out by the slow running queries. Here, when you find out that a query is slow running, you may be able to start, stop, or even restart a query. So you can sort it according to slow running queries, or queries that eat up all your CPU or eat up all your disk or IO. You can sort it according to that, and then you can find out which query is actually slowing down your application or your database, and perform a remediative action for it. So that's the same with databases as well. You have the details of all the databases. Then you have the session details. So for the database, in the database cluster, you have individual databases, right? Like, so for each individual database, you get the disk utilization, transaction details, a lot more metrics. Then you have the session details as well, where you can monitor the connection times, the user connection, the logins and logouts. So this is basically useful for when you have active sessions and the database connection pool is not able to handle it, like we saw in section 4. And then you also can monitor the jobs, the backups, the restores, etc. So here you will be able to monitor the restore backup details, the restore details. So here you don't have to individually go and check up all your backups or all your restore details. You can just assign an anomaly detection profile or a threshold profile to all of these and get alerted only when it's not performing properly. That way, you reduce the manual checkups and manual time spent on it. Then you can also monitor the replication details, the statuses, the publication, etc. Then you can monitor the user details, the cluster details. So all of these this is not just monitoring. Like I said, it's an observability. So you get to configure alarms and associated with threshold profiles. So the threshold profiles, so we have 3 types of threshold profiles. One is the normal fixed profile, which is used in your normal monitoring dashboards. Then the second one is adaptive threshold profile, which is where you have an option to choose, automatic or a manual one. So in the automatic, if the deviation percentage is less than or greater than a certain threshold limit, it will give you an alert. And in the manual one, you can set it against certain baseline values or custom expressions. So if you find out that suppose the first week of January was your best performing week, then you can compare it with that baseline and get alerted each time. But there's also custom expression where you can select the custom expression as well. So when you come to anomaly detection, so this is basically for getting alerts on incidents, right? So for anomaly detection, you can get alerted whenever there's a performance deviation, when it moves away from the ideal performance, say. So here also you have baseline values, where in the adaptive threshold profile, we had fixed baselines, right? So here you also have a moving baseline, which is based on the previous week's data. You can fix it against your one ideal threshold, or you can fix it based on the previous week's data. And you can also specify it as a percentage of that week's data. Say if your ideal week's data, say if your ideal week's CPU percentage is 50%, then you can specify it as 20% of that 50%, which would be 10%. If it goes below then 10%, then you will get an alert. And you can specify the lower or the upper limit as well. So specifying this will get you to that prevention step, right, from the find, analyze, and fix approach. So this is it about our tool and how it looks like and how it helps you prevent everything. So that is it with our webinar. So let me recap one more time. Before I recap, you would get a poll about how the presenter, how informational it was to you, or how beneficial it was to you. So please take a moment to answer those polls as well. It will help us with our webinars in the future, whether it was informational or beneficial. Any comment is appreciated. So let me recap while you answer those polls. So we had six shifts and one outcome. So in section 1, we talk about how the burnout is structural. It's not personal, but structural, how the game is stacked against the database admins and the statistics to support all of that. Then we saw how traditional monitoring just can't keep up with modern complexity, right? And in third section, we saw how we can fix that with observability. And we have the find, analyze, fix approach to it. And in fourth section, which was the bulkiest section of them all, we talked about the metrics that you need to monitor, how to monitor, and what metrics contribute to which root causes contribute to what metrics or what kind of issues. And we also talked about how to prevent it with certain anomaly detection and automated remediation. So this is backed up by science. We had a poll that we ran on some of the database communities, and almost all the experienced people, almost all the experienced database admins who never really had a burnout or who had a burnout and overcame it, they stand by automated remediation and anomaly profiles. So that is the only answer to actually resolving the technical aspect of the database admin burnout issue. And finally, we saw how the right platform changes the math. So we saw how Manage Engine can help resolve it. And we also saw a live demo of it. So this is what we covered in today's webinar. So thank you for being here. I hope this hour got you a little closer to that 2 hours of strategy instead of the 24 plus hours that we talked earlier in the beginning. So take care, everyone. Thank you.